920 plus 2x minus 0.02x squared, and plus, I think I see correctly, 1, 2, 3, 4 zeros. 1, 2, 3, 4, 7, x to the third. Okay, and we're asked in part A to find the marginal cost. Marginal cost by definition is c prime of x. Not a big deal. Can anyone give us c prime of x? Who would like to give us c prime of x?
Is it going to be, well, the first constant just turns to 0, and then it's going to be 2 minus...
I'll help with that. Yep.
Yep. And then plus 3 times that.
0.00021 x squared.
Yep.
I normally like it as a clean ship, right? 0.0021 x squared and minus 0.04 x and plus 2. Okay, that's the marginal cost. In part B, they're asking us to find c prime of 100 and explain its meaning. So I have 0.0021, I swallowed the 0, 21, and this is times 100 squared. When I multiply this by 100, I get -4 and plus 2. So I move to, 2.1 minus 4 plus 2. So 4.1 minus 4 is 0.1. So correct my mistakes, plug it in yourselves. If you get something else, let me know right away. So this is, of course, in dollars per unit. The cost, the rate of change of the cost when we manufacture 100 units. Rate of change of cost with respect to number of units is increasing by $0.1 per unit when producing 100 units. Are my numbers correct, everyone? Well, you'll let me know. Okay, in part C, and this is what I wanted to get to. In part C, they're asking us to compare c prime of 100 with the cost of producing the 101st item with the cost of producing the 101st item. So you understand what happens here. We want to find C of 101. What is C of 101 approximately equal to? And I'll wait for you to discover this. I need this to come from you. Collectively, that would be great.
It's approximately 100, right?
Okay.
Or maybe not.
The cost of 101, this is the 100, and this is the dx, equals that. I'm ready. So where x is 100 and dx is 1. Who would like to help?
Is it just like 100 plus 1?
This is the 100 plus 1. This is the 100 plus 1. Ready?
C of 101 is going to be 990.1.
So x is 100, dx is 1, and we want to use the formula from last time.
Is it C over 100?
Excellent.
And then plus the derivative of
Excellent. Multiplied by?
1.
Exactly. Exactly. Thank you, Isaac. Very good. Very good. So it's f of x plus dx is f of x plus f prime of x times dx. Great job. Thank you. So I'm continuing here. C of 100, I don't have. I have to determine C of 100. So I have 920 plus 200, right? Minus 0.02 times 100 squared, and plus 0.1234, times 100 raised to the third power. I got 990. So 990 plus C prime of 100, which is 0.1, because we determined it. So this is 990.1. And this is C of 101, which is in dollars. It's the cost, is not the rate of change. So this is what we get with the approximation. Now we want to find the exact cost because we are asked to compare C prime of 100 with the cost of producing the 101st item. So this is the cost for producing 101 items. This is not the cost of producing the 101st item. The exact cost of producing the 101st item is what? Can anyone give us the exact cost of producing the 101st item? Is our delta y, which is C of 101 minus C of 100. So I have C of 101. No, I have the approximation for C of 101, but I'm going to just change 200. I'm just going to change 100 into 101, I meant to say. So maybe I should just create a function and plug it in. That's much better. 920 plus 2 times x minus 0.0202 x squared plus 0.12347 x to the third. Where's my 3? Okay, good. So now I'm just going to plug in 100 and 101. Done. So C of 101, I got 990.10107, and C of 100 is 990. So this is 0.10107. This is the cost of the 101st item in dollars. And now you see why dy is approximately, delta y is approximately dy. One more time. What was our delta y? This one, 0.10107. And here is our dy because it's multiplied by 1, 0.1. So dy was determined by simply finding c prime of x times 1, because dx is 1. So we got 0.1. Look at how much work I needed to. I had to put a function in the calculator and plug it in, etc., etc. So this is the exact value. Are you happy with this approximation? If we say 0.10107 is approximately 0.1, would you accept? Would you agree with that? Is that okay? Is that good enough?
Yes.
Yes.
Yep. So that was the idea. But this is a specific situation in which delta x is 1. And it's still a good approximation. You can say, but 1 is quite big. Not when it comes to items. But I like to look at another problem. If you remember, we talked last time about my props here. I have an error in the length. How does that translate in the error of the volume of my prop? I have an error in the length that must trigger an error in any function, like the volume or surface area of my prop. Okay, so let's take a look at a disk. And then I'm like to wrap up this section and move on to the very last one. Okay, so it says the radius of a circular disk. Radius. Oh, I'm sorry, forgive me. Any questions on the previous problem? So the exact was this, the difference from 101 and 100, and this was the differential of the cost for the dx being 1. Any questions on the previous problem?
I have a quick question.
Please do.
How did we determine what x was equal to when we said it was equal to 1? The difference between. Okay. thank you.
Right. So here we're talking about 100 and then 101. So it's a very good question. So if I'm asked to find 101, then in this case, for the cost of producing the 101st item, and all the discussion was about producing 100, so the extra unit, that's the delta x. If you want to call it the error in x. It's not an error, we want to, but we can also call it an error in x, which is dx. Very good, thank you. Is that okay?
Next question is,
Yes, Gia, go ahead. Say it again.
what number was this question again in the textbook? What was the question?
The one that we just did.
Yes.
From the review at the very end of chapter 3, it's this problem here, 92.
Okay.
It's in the review at the end of chapter 3.
All right. Thank you.
It's I wanted another marginal cost situation. So now I'm back to section 3.10 to wrap that up. With the radius of a circular disk, the radius of a circular disk is given as 24 centimeters with a maximum error in measurement of 0.2. So the radius should be 24, but is either short or long by 0.2. Okay. Use differentials to estimate the maximum error in the calculated area. Max error in calculated area using.
Professor, the right side of your paper is a bit cut off. Do you mind just moving it to the left a little bit? Yeah, that looks a lot better. Thank you.
Oh, sorry. I'm not looking over there. I'm looking over here. So that's why I'm sorry. Sometimes I may.
No, you're good.
So keep me on the right track. So maximum error in calculated area using differentials. as in my little silly example here, if imagine this is a circle, if I have an error in the measurement of the radius, that will trigger an error in the measurement of the area. And we want to approximate that. We want to determine that.